Everyone, welcome to MLAS 800, and we are in Learning Activity 7. We've got a lab that's going to wrap up our week, and that'll be our last learning activity for this week. In this lab, we're gonna do a follow-up of our lecture where we went and focused on different aspects of large language models and techniques for prompt engineering. I wanted to dive into a little bit more detail in this lab to go through 4 different types of techniques for prompts. Remember in our lecture, I showed quite a few more prompt and prompt techniques. So there's a good 30, probably 30 to probably 40 now different types of prompt engineering styles that you can go after. I'm not going to go through all of those because I want there to be time for you to explore other techniques. So I'm going to go through 4 today in our lab. We're going to focus on what's called zero-shot prompting, and then the next, of course, off of that would be few-shot prompting, and then we're going to go to the more prevalent or more well-known chain of thought, and then I'm going to wrap up with what's called tree of thoughts. And with that'll wrap up what we'll do for our lab today. So let's start with zero shot. Right now, I've got we're going to use ChatGPT. Just go ahead and log into OpenAI, and we're going to use OpenAI's large language model and work with that. And I do encourage everyone, I'll mention this and reinforce at the end of the lecture, that our DALL-E large language model, I encourage you to try that with a much smaller model. OpenAI is going to be a lot more polished because it's a much bigger large language model than what we've been working with in our local instance. So it'll be fun for you to be able to see the differences between what you see in OpenAI, which is going to be much more, again, polished than what we'll have with a much smaller model. So let's jump into zero-shot learning. For zero-shot learning, or I should say zero-shot prompting, it means that we're going to be providing the large language model a domain-specific task that it hasn't been trained on. And so we're going to provide it data that we're going to make it make a determination on. So in this case, we're going to actually do sentiment analysis on some data that we're going to provide it. It's very simple. And what's going to happen is I'm going to say, hey, let's classify text into neutral, negative, or positive. And then we're going to provide a narrative of what it is that we want to classify. So in this case, it's going to be something that it has no knowledge of, which is a vacation day, just something that is today's vacation. So I'm going to say classify the text into neutral, negative, or positive. And in this case, I'm going to provide it with a some data that it doesn't have any reference to, which is your personal thought. So I'm just going to say, I think the vacation is okay. And so that's going to be a clear context of zero-shot prompting, because it has no knowledge of what my thought is as it relates to what my perception of a vacation is. So it's going to have to make a judgment call based on no data whatsoever, only based on what it's provided in its training data, and then it's going to make a classification on the sentiment. So I'm going to set enter, and so it says the text, I think the vacation is okay, would generally be classified as neutral as it expresses a moderate or indifferent opinion. So that's perfect. That's exactly what we wanted to come out with. And that means that in this case, it did a very good job of zero-shot prompting and got it classified properly. So in other words, if I gave this prompt to a human, remember, like I'd mentioned before, when you think of prompt engineering, it's the same concept as if you were talking to a human. So any other human, just like any other learning machine, it's going to be a conversation. So we're prompting this large language model, and in this case, it got it right. And so if we changed it up to say, hey, classify the text, just do the same thing, classify the text into neutral, um, neutral, negative, or positive. And then I say the same thing, and we'll do one more, and then we'll move on to the next one. The vacation is let's give it something a little bit more descriptive. Let's say is legendary, and we'll go here. We'll see. And so we would expect that it would say that it's a highly favorable, and it does. And so it finds it is classified as positive. It expresses a highly favorable opinion of the vacation. So that's perfect. That's exactly what we're looking to find. And so if you think about again, large language models, um, they have some basic understanding of sentiment, but this is a clear zero shot capability that it's expressing because it doesn't know what my sentiment about the vacation is. So I'm expressing my sentiment, which it has no knowledge of, which means that it clearly got it right. So that's and you can actually see zero shot learning in action in a lot of large language models in a lot of other domains. So the next evolution of that is few shot learning. There's actually one shot, two shot, three shot, five, 10. And so when you start to get past 10 samples from a statistical perspective, we're starting to get into a situation where um, there's a clear statistical sample that gets you into a domain that is starting to build data up, a historical data reference on, and it's no longer a zero shot or a one shot or a 10 shot. It's starting to actually be incorporated into its database. So that's something to consider when we talk about these type of learning metrics. All right, apologies. I had to pause there for a quick second to get connected to get my battery back up and running. Okay, so next up is few shot learning. We're going to go ahead and jump into what that looks like. And so we've seen that large language models have a good zero shot capability. But there's sometimes where we want to provide, and this can be used both ways. I'm going to actually have some fun with this. But when we get into providing training data, we can actually, it's very powerful. We can actually have the large language model exhibit some creativity and go into a direction that provides additional context, and in this case, a completely made up animal. We're gonna create an animal that doesn't exist, at least in the context of, I don't think it exists in the lexicon of, we've never found this animal. But if I give it a little bit of information, a large language model can actually extrapolate that and go even further. So what we're going to do in this one, which is a few shot example, is I'm going to create a what poo. It's literally, that's what we're going with, what poo. And then is a small furry, so we're going to create the context for this, is a small furry animal, and animal, and can you use this in a sentence? And then this is a very, very simple few shot example, because I'm providing the context of it's an animal, and then I'm saying, hey, within your database of what an animal is, I'm going to actually say use it in a sentence, but I'm going to go a step further. I'm going to say provide a habitat, because this is what makes this interesting about these models, is that with these large language models, you can actually have it go pretty far and get pretty creative. So I'm going to say provide a habitat description of the animal. Description of the animal. And then I'm going to say as well as a description of the animal itself. And a description of its eating habits. And a description of its eating habits. Okay. Let's see what it does. So, you can see here that OpenAI is going all in on what we just provided it. It didn't even bother to cross-reference if an animal what poo exists. Now, I will follow up with this because here's what I do want to make sure that's why you gotta cross-check your large language model data and the output that you get, because I just fed it a bunch of junk, and then I got junk back. So I got a what poo is a small furry animal native to dense forests in temperate climates. It's characterized by fluffy brown fur, tiny round ears. This is an animal that doesn't exist, but the large language model just ran with what I provided it. This is a perfect case of a few shot example, or a few shot prompt. So I gave it a little bit of information, and then it built an ecosystem up around that. And I gave it a little bit more, and it went even as far as saying it resides in hollowed out tree trunks, burrows lined with soft moss and leaves. It created a whole storyline around an animal that's completely fictional. And again, this is something that you have to cross-check. Now, the good news is that if I went in and said, hey, now I want to provide additional context, and then I asked OpenAI, does this animal exist in the real world? Let's see what happens. Does this animal exist in the real world? Or world, not worlds. Alright, and my connection's off. Let me get my connection back. Okay, I think we're back. So we're gonna reconnect. We're gonna rerun this. And then so it accurately describes, no, the what poo as described is a fictional or hypothetical animal created for the context of our discussion. So it rightly asserts that it is not a real animal. And again, when it comes to ChatGPT and OpenAI models, they will answer the questions that you give them, and they will entertain creatively the questions that you give them. But you have to always make sure that you're grounding it in reality, and that you're being logical and scientific, if that's the intent. And so, if you're using a large language model to be creative, that's fine too. You just have to be careful. Okay, so that's a perfect example of a few shot learning technique. The next one is going to be that brings us to our third one, which is a chain of thought. And so a chain of thought is a more it's a prompting style that enables more complex reasoning. We did a little bit of that here with the few shot example by doing a little bit of back and forth. And so we're actually going to go a little bit further now, and the early versions of large language models actually had trouble with what we're about to do. The OpenAI now has a much more comprehensive capability. And so let's go ahead and go into what we're going to do here. So I'm going to say I went to the market. And bought 10 apples, period. So that's the first thought that we're going to send to OpenAI. The next one is I gave 2 apples to the neighbor, and 2 to the repairman. Okay. I then went and bought 5 more apples and ate 1. how many apples are remaining? How many apples are remaining? Okay, so now early versions of these large language models. Let's looks like I lost my connection again. Okay, looks like I got my connection back. So let's go ahead and run this. And in early versions of this, when we would provide this, it makes short work of this. But large language models, early versions of this would occasionally trip up and think that there were 11 apples, and you can actually follow this chain of thought pretty easily. If you went to the market, you bought 10. I gave 2 apples to the neighbor and 2 to the repairman, right? So it's going through, and then I went and bought 5 more apples and ate 1. And I even made a mistake. I said, and at 1. How many apples are remaining? It's actually there's 10 apples, and so if you initially bought 10, you gave away 2 apples to the neighbor and 2 apples to the repairman. So that's 2 plus 2 equals to 4 apples. Remaining is 10 minus 4 equals 6 apples. Then you bought 5 more, which gives you a total apples now 6 plus 5 equals 11. But then you ate 1 apple, which means that you've got 10 left. And so and what ended up happening is chain of thought, large language models would trip up on that very last step. And so that was one of the things that as time has gone on, they actually have gotten to the point where these large language models are able to even solve traveling salesman problems that are way orders and orders of magnitude more complicated than this. But this is essentially a very, very, very simplified traveling salesperson paradigm. So with a lot of the new large language models, you can feed them these chains of thoughts. And so this is that. And so to give you an example, or I should say to expand upon it, each one of these sentences here, I went to the market, I gave an apple, and then I went and bought 5 more, and then I ate 1. Those are all, that's a chain of thought. Like it's a stepwise, step 1, step 2, step 3, step 4. And large language models are actually really good at going through and providing really good, accurate results if you help them along at each step of the way. And in other words, you provide them a stepwise serial fashion of, for a problem, do this first, then do this second, then do this third. And you can actually use this for all kinds of manner of tasks, not just for math problems, but these could be for architecture problems, design problems, ordering problems that might be a little bit more complicated to visualize. So and then sorting problems as well. All right, well then you can actually, if you want, I'm going to let you go through this. You can actually create a simplified version of what I just did, and just you can whittle this down to, I bought 10 apples, I gave 2 apples to the neighbor and 2 to the repairman, and then I went and bought 5 more. What's left, right? You can even simplify that and see what it does, and you should get the same result. Okay, last up is a tree of thought, and so for complex tasks that require exploration, like or strategic look ahead, or that goes beyond just kind of simple rote memorization, classification, or clustering type of exercises where you say, hey, I have apples and oranges, look at this image and tell me how many I have. That's how many I have in the image. That's a very standard classification. It's a machine learning, artificial intelligence. It's a very specific classification. I mean, it is a very, very classical classification algorithm that you would run through. Now, in a tree of thought, and this kind of gets borrowed from random forest, what we call random forest algorithms. They're very good at looking ahead for prediction. So not just classification, but what's going to happen next if I'm going to do forecast. So for example, if I don't just tell me that is today going to be rainy or today is going to be sunny, but actually tell me next week what's going to happen. That's a very strategic look ahead. And then on top of that, don't just tell me that it's raining next week, but advise me as to what should I be wearing an umbrella, or I should say, rather, should I be taking an umbrella with me, or should I be wearing a raincoat, so on and so forth. That's actually another level of advisement that is where Tree of Thoughts are really good with. So here's, and you can actually, you can get pretty creative with this. So so let's go ahead and jump into what a tree of thought is. So imagine 3 different experts are answering this question. And so what we're gonna do, this is pretty wild what the new models can do. And what we're gonna do is we're gonna infer a question based on very abstract information that we're going to give to the large language model. All experts will write down one step of their thinking, then share it with the group. Then all experts will go on to the next step. And we're going to say, etc. We're going to actually say, etc. And then if any expert realizes they're wrong, I'd say they're wrong at any point, then they leave. The question, and then we're going to say that's actually what this is about, is what is the question, just based on the limited amount of information we're providing it. So the question is ... And let's clean some of this stuff up here. We'll say there, and realizes, okay, at any point then they leave. The question is, okay, so sure, and then what you get is this really long, and so this is what's interesting, is I'm gonna do this a couple different ways. Now, this is an example of the large language model is actually looking back and using the training data in the thread that we just provided it. And I kind of don't want it to do that. I need to set up a separate, fresh session. So what it's doing is actually it's going through 3 different experts might approach the problem as it relates to the apples in the example that we just provided it, and I don't want it to do that. So here's an example of it learning that I'm actually, or inadvertently, I'm actually saying, hey, do an analysis of the apple conversation we just had. So I'm going to actually open up a new window, and I'm going to redo this. So this is actually good because this was unintended, because OpenAI is taking what you learned in this prior chat here, and it's applying the question that I just asked it to the training. It's using our conversation as training data to interpolate the next step, which is kind of not what I wanted to. I want to show something a little different here. Okay, so I'm going to set up a new session, and we're going to come in here. We're going to say, imagine 3 different experts. So in other words, this is a little bit of of zero-shot learning with tree of thought all put together, because I'm actually asking it to infer a question with very little information. Let's see what we get. So this is the question it should come up with, and this is what I was looking for. Is it the question that gets inferred from what we just asked it is, what is the most efficient way to reduce carbon emissions in urban areas? And so this is it's a very interesting thing, because that's what it decided was that it was going to jump ahead to, and it made a strategic decision that was the question based on the limited amount of information. Now the reality is that it could have said, what is the most efficient way to drive a car, what's the most efficient way to fly an airplane, right? Based on what we just provided it, any one of those would have been legitimate. And that's okay. What we're actually looking for is that it could actually extrapolate and provide a question to begin with. And that's kind of what if I had prompted a human to do that, a human would come up with something completely different. But it's not that it didn't give a question, it's that, that it did not give a question. The fact that it gave a question, that's a very, very advanced reasoning capability. And so we could actually fine tune this, we could provide more data, we could give it more information. And then of course, like we saw, if we give it a lot of information, then it refined it down to a question and answer series related to the Apple conversation we had earlier. Okay, so that's all I've got for this lab. What I'd like for you to do is go through the lecture and try a few more. There's a couple more that you can go through. There's a chain of symbol, and then there's a generative prompting, and then there's self-consistency prompting. Again, there's a lot more that you can run through, but try a few more. They're going to be real helpful as it relates to how you approach your autonomous systems design paper, your midterm paper. And I'd love to see some of that incorporated into your design proposals. Of course, that I would very much like to see that incorporated in as well into making that into your final paper for the term. So, okay, if you've got any questions, as always, feel free to text or email, and I will see you in the next learning activity next week.